VLPSos here. This is a video lesson for Python programming, decision making. These videos are made with the intention that they may be paused so that you can practice. Recall that code can be executed on condition. I've written a conditional statement. The condition is checking to see if playing is equal to true. Notice the double equals. This is not an assignment. The double equals is like a question, is playing equal to true? And if it is, and only if it is, it will run the code block that's indented under that conditional statement, those two print lines. If I was to run my code now, and we'll see what happens, I expect an error. And I indeed get an error. It says name playing is not defined. So if it's checking to see if the value of a variable is equal to true, and it has no value assigned to that variable previously, then it will throw an error. So we're going to define playing and set it equal to true. When we do, we can now see that the condition does not error, and it indeed uses those print statements because the condition is true. The condition playing is equal to true is evaluated to be true. If it didn't, we would not see the print lines executed. I'm going to write another similar conditional statement. If playing is equal to false, then we will print as if the program is no longer playing and the intention is to tell the user that the program is over. We could print something like, thanks for playing, and then be very clear that the program is over with a bye. If I run this, I do not see those print lines executed. I don't see that we're finished playing or bye because the value of playing is equal to true. So this condition, the question, is playing equal to false, is a false statement. So it does not run that code. I could reassign the value of playing to be equal to false, and I'll do that in the code block above. Now what's going to happen is playing is assigned to be true, it's checked to be true, and it runs this code block. Included in that code block is a reassignment so that when this one is tested, playing is equal to false, and then it allows that code block to be executed. We can observe that happening there. This isn't necessarily decision making yet because there's only one condition in each example. The above condition evaluated true because the value of playing was reassigned to be false, making the condition true. So be careful to note the difference between a variable being true or false and the condition that the variable might be in. We can write code that responds in two different ways to make a decision of sorts. The examples that we've shown before, there are two of them, only check one thing and do one thing based on that choice. But we're going to write code that's a little more sophisticated. And to begin, we're going to reassign playing to be equal to true so that we can use it in a condition. And we will print, I'm going to save time by copying and pasting these lines just like before, but we're going to make our code more sophisticated. In this case, we're going to introduce what's called the else. Else will have its own code block. Notice that there isn't a condition between the keyword else and a colon because it's this code block that will be run if the first condition with the if keyword is not true. And in this case, I'm going to copy these lines from the above example. The first two examples in the sort have been combined. we test one condition with the keyword if. If this condition tests true, we run its code block. But we have now an else, which means that if this is false, then we'll automatically go to the code block under the else keyword and run it instead. So we can see these lines from the first two examples, and then another playing a game still playing, because playing is equal to true was the code block that was chosen in this example. If I now reassign playing to be false, let's see what happens. We know playing starts as true, and we can see that playing a game was printed on condition that playing was true, and we expected that playing was reassigned to be false. But notice that it didn't automatically run this else condition. That's because this is one decision. We're either going to run this code, depending on if this condition is true, or else run the other code, but not both. We can't do both in one pass of the program. Even if we reassign playing to be false, then we're not immediately then going to run this code that would be run if playing was false the first time we checked. If I reassign playing to be false up here, so it's false when we run and check this condition, we can see that the behavior has changed because it's saying bye to us again. Notice the else code block didn't execute even after playing was reassigned because the condition was only evaluated once. Let's get more sophisticated. We can consider many conditions within the same decision. And in this case, I'm going to define a new variable and set it equal to an integer value. 88 is assigned to the variable number. And we can write a condition with an inequality that tests whether the value of number is less than 0. And if it is, we will print the number is negative, because if a number is less than 0, we could also call it negative. Then we're going to introduce an elif statement. This is testing another condition if the one before it was false and didn't execute its code block. In this case, it's like combining an else and an if. I'm going to write another condition. In this case, if the number is less than 10, then I will print the number is between 0 and 9. Now, to be less than 10 means that you're going to be 9 or lower. But this print statement says between, well, it will, 0 and 9. How do we know that we're not lower than 0 when this line, this condition, has been tested? It's because we will only test this condition if the first condition above it with the keyword if was false. So by the time that we get to testing this condition, it already must be true that the number is not less than 0. And so the print statement is accurate. There is an order to these conditions that are tested. I'm going to add another one, another elif statement, which is a combination of else if. The else part means something above it didn't test to be true. And so you've gotten to this place in your code. And if means we're going to test another condition. In this case, we're going to test whether number is less than 100. And if it is, we'll have another print statement. And again, this is an accurate print statement because even if the condition less than 100 would include numbers like 8 and -3, the conditions that throw out negative numbers and numbers between 0 and 9 must have already tested false. So by the time we get here to make this test, the print statement that the number must be between 10 and 99 is accurate. And finally, I'm going to end this decision code block with a else statement, which means that all of the other conditions above must have been tested false in order to get here. And we'll simply report that the number is large. More precisely, it's 100 or greater. Let's see this code block run. And if the value of number is 88, we got what we expected. The accurate report that the number is between 10 and 99. So we'll note that elif is a keyword. Elif is a combination of else and if. It allows for other conditions to be tested. This code structure is hierarchical, which means the conditions are tested in order. The first one that evaluates true will have its code block executed. All other lower conditions will not be tested. So in this case, the flow of the interpreter read these lines in order from top to bottom. It tested this condition and it tested false, so it skipped down, and if there was an else or an elif, it tested, in this case, another condition. This tested false, so it skipped down, tested this condition. This condition was true, so this is the code block that was run based on that conditional statement being true. And after it finished this code block with this single print line, it skipped the else. It would have skipped all other tests of conditions and then kept running if there were code beyond that. And to be clear, notice that the condition number is less than 100 does not need to include testing if the number is less than 10 to correctly report that it's between 10 and 99. That's because the conditions above have already ruled out the possibility that the number is not less than 10. Again, and this is very important, if this condition tests true, then it implies if the computer interpreter gets to test this condition, it must be the case that all previous conditions were tested false so that you can code accurately. Let's have one more example. In this case, we're going to use a string and assign the initial value to name, the string Catan, and then write a conditional statement if name is equal to sauce, then print hello master. A little bit of ego humor. And then write an elif condition if name is in a list this time. Then run or execute the code block. In this case, this is an example that shows that a decision does not need to include an else statement. The simplest code uses if statements. You can't automatically start a decision with an elif. An elif can only follow if you first start with an if. And every time you use the if keyword to test a new condition, you're writing a new decision. So I've used the keyword if here, and this structure is a single decision independent of the other structures, each starting with an if. And again, we don't need an else. If we were to run this, we can see that it said hello masterling because the value of name was within this list. If I change the name to be something like SOS, notice that it's not capitalized, and I run this, I don't see anything printed. There was no else condition to do anything. The capitalization in a string is important, so when it tested this condition, it wasn't an exact match, therefore it did not run this code block. Then it tested whether the name was in this list, and it's not, so it didn't do anything else. There was no else condition. There's a lot to play with here. Now you. Practice by writing a decision process with several conditions. Suggestion: make one that checks input from the user and responds differently to you, your friends, your family, and has a default response for others.